Hello, my name is Dr. Richard Venditti, and I'm with the Paper Science and Engineering program at North Carolina State University. And today what we're going to do is a flotation deinking virtual laboratory. First, a little bit about flotation deinking. Flotation deinking is a process in which we separate hydrophobic contaminants away from pulp fiber stock, and we use air bubbles to actually do this. So what is happening? Contaminants like ink are hydrophobic. They want to come out of water. They do not like to be in water. And what happens is when they see an air bubble and they contact that air bubble, they stay with the air bubble and they get lifted and floated to the surface of the flotation deinking cell. This actually separates the ink from the fiber. Now the fiber is what we call hydrophilic. It has a strong affinity for water and wants to stay in the water. So when it contacts air bubbles, it doesn't attach as strongly or as much as the ink. And so that's how we get our separation. It's air bubbles lifting ink particles up to the surface of the flotation cell to separate. Now this is a picture of an industrial flotation cell. And what you'll see here is that, so here's our feed right here, and the pulp comes through this tube, and then actually right here is an aspirator. It's just a hole in the pipe, but it's well designed so that when the fluid is flowing down through here with the fiber and the ink, air gets sucked in here, and then air bubbles are formed. The air bubbles attach to the ink, and then the ink and the air bubbles come up to here, and then they form in this area right here. This is a stable foam, and then that foam, as it builds up, it gets knocked over this ledge right here, and this knockdown shower helps us get the foam over here. So this foam right here is our rejects, and that's going to have a lot of the ink. Now the good fiber actually is coming through here. It sees the air bubbles but doesn't want to attach as much, and it actually comes down into the bottom here, and then it's pulled out this way from this pipe, and then actually the process is repeated again in a second section of the flotation cell, and then a third, and then a fourth. So we have 4 actual flotation processes in a row. Over on the right, you can see an industrial flotation cell. And here's one flotation cell right here. And you can see that these right here are the feed to each section. And then the other thing you'll notice right here is a chemical. This is a foaming agent. And that foaming agent is added so that we can make a stable foam so that the ink air bubble foam doesn't collapse and the ink go back into the pulp suspension. This is going to be our recording table where we're going to record data. The things that you need to record in this lab are the weight of the original sheet of paper and then the weight of our product after we floated. And then from that you're going to calculate the yields of our process. The other data that you're going to need to record during the lab is the parts per million of the unfloated sheet or the feed sample, so right there. And then you'll also need to record the ppm of the floated sheet, our final product, right there. And then from those 2 numbers, you're going to calculate what's called a cleanliness efficiency. It tells you how much cleaner the accept is relative to the feed. This is going to be the sheet of paper that we are going to de-ink, and it's just a regular copy paper, sheet of paper, but with some heavy ink toner put on it. First thing we'll do is we'll weigh it and then record that number. Then after we weigh it, we will add water to a common household blender. That's going to be our pulper, and we're going to tear up the paper so that it fits into the blender. Once the paper and the water are in the blender, we're going to put it on the motor, and then that will cause the agitator to stir. We're going to blend it for a prescribed time. Now what happens in the pulping process is that agitator is going to hit the paper, and it's going to tear apart the paper into individual fibers, and it's also going to detach the toner from the surface of those fibers. This is the product of the pulping. What you can see is that there's ink particles that have actually floated to the top by themselves, and this is what we're going to float. We're looking in that pulping process to separate fibers and also to detach ink from the surface of the fibers. Now what we'll do is we'll set up the flotation deinking process. So we'll put the beaker into a shallow aluminum pan, and then we're going to add foaming agent to our pulp suspension. That foaming agent is going to make the foams more stable so we can scrape it off. Now the next step is we add water, and the only reason we're doing that is to get the pulp suspension up close to the ledge of the beaker so that the foam has a short distance to travel to get over the ledge. Then what we'll do is we're going to add the air pump. So this is just a regular aquarium air pump. It's got a diffusing stone, and you can see once I submerge it that the air bubbles come out. And so those are the air bubbles that are going to attach to the ink and then float to the top. So as we go along, you can see here's the foam, and you can see right there that's that black dark spot. That's just an example of a highly concentrated ink area that has been floated off the top. What we're doing is we're looking for as much good foam as possible, and what we want is ink in that foam and as little fiber as possible. Now some fiber will go off, but we try to minimize that. So here we are scraping that foam off the top of the flotation cell, and the foam goes into the pan, and so the pan is going to contain our rejects, and then the accepts stay in that beaker, and in the end we'll just take those and use those to make a hand sheet. Here's a close-up of those foam rejects, and what you can see is that black material. That's the ink that we are trying to remove, and if you look real closely you could see some fiber in the rejects. We don't want it there, but it's inevitable. And here you can see some more foam coming off the rejects. Now the next step is the accepts that were in that blender. We're going to make a paper sheet out of that. So this is our hand sheet molds, and it's got a paper machine wire. It's much like a screen porch. It's got plastic wire with holes in it. We got to get the air bubbles out of the bottom. And then what we'll do is we'll take our accepts and we'll pour it into the mold, and by pouring it vigorously we get the fibers to mix and disperse, and then we carefully lift up the mold and the water starts draining out of the wire. And then once most of the free water has been removed, we're going to then open up our hand sheet mold and then press the sheet. There's a good close-up of the wet, weak web. We've got to be very careful at this point. We take the hand sheet mold top off, and there's our sheet. Then what we're going to do is we're going to use blotter paper, and we're going to try to press as much water out as we possibly can. And during that pressing, what we're doing is we're consolidating the fiber web and making it just strong enough so that we can take it off the paper machine wire. So you can see we're pressing very carefully up and down to get rid of as much water as possible. And then we will actually, eventually, after we press enough water off, we just were successful in couching, or taking off the paper from that wire and putting it between two blotter papers. Then the final step to remove the remaining water is to put it on a speed dryer. So this is at a very high temperature, above the boiling point of water, and we wait there for about 4 minutes and let all of the water boil off the paper. Then we have a strong sheet of paper. Now once that paper is dry, we're going to put it on the balance, and we will record the final product weight. Here's a close-up picture of our flotated paper. You can still see there's some ink specks, but not a lot. Now this is actually an image of the feed, and you can see a lot more ink. So this image right here, on the right we have our floated sample, and on the left we have our feed sample. You can see the feed sample had a lot more toner to it. Now our last step is to actually determine how much ink we have in the floated sheet and the feed sheet. So we just put the floated sheet in, and we're going to run and we're going to scan an image of it, and we'll get a nice image of it that goes into the computer, and the computer actually recognizes the dark spots as ink and colors them red for us. We actually scan both the front and the back side of the sheet, and next what we'll do is we will look at those image analysis results of the feed and of the accepts in more detail. This is our image analysis results. We've got the feed on the left and the accepts results on the right. The image analysis system actually gives us the distribution of ink particles, and it just kind of draws a little map of very large particles up here and then small particles here, and you can see how much are in the feed. The accepts also results show a very different distribution, and so what you'll see is that a lot of the large particles in this region right here have been removed from flotation, and yet we still have some amount of the smaller particles. Now what the image analysis does is it counts up all the areas covered by dark spots, the ink, and then it divides it by the total area that it scans. And what it does is it gives you what's called a parts per million. Parts per million is simply the fraction of the paper that's covered by ink or dirt or dark spots times 1 million, because usually it's a small number. And what you're seeing here is that our feed sample has 5496 parts per million. That actually result is right here. We took it from right here. And then the accepts has a parts per million of 386. We took that number from right here. The image analysis gives us a whole bunch of different statistics, but what we'll use is the feed ppm and the accepts ppm for our calculations of ink removal efficiency. Okay, now that we've done the virtual deinking laboratory, flotation deinking laboratory, we'd like to summarize what we learned. Okay, first important point is that flotation separates contaminants away from fibers based on their hydrophobicity. The second point is that good detachment of the contaminant from the fiber in pulping is required for flotation. In other words, you cannot separate ink from fiber unless it's detached, and the detachment occurs in the pulping. And then the final point is that yes, in flotation we want to have a maximum ink removal, but the other issue is that we want to keep a high fiber yield, and usually ink removal and fiber yield are opposites, and so we have to have a certain balance. We don't want to throw away too much fiber, and yet we want to have a clean product. That concludes our virtual flotation deinking experiment.